Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of derivative rules. So we have to differentiate each of these six functions. So let's start with part A. So in part A, we are given a polynomial function. So we can write our first step as, so we can change y to dy over dx, so we can use the Leibniz notation. So we get dy over dx equals, so we get the derivative of 3 times x to the power 5 over 3 over dx. Sorry, this, right? So now we can use the constant product rule. So 3 is the coefficient of the term, so we can move the 3 out of the derivative. So dy over dx equals 3, and now we get the derivative of x to the power 5 over 3. And now we can use the power rule of derivatives. So we get dy over dx equals 3 times. So we get 5 over 3, and then x exponent 5 over 3 minus 1. So the exponent became the coefficient. So now in the next step, we can multiply 3 by 5 over 3, which is equal to 5, and then x to the power 2 over 3. So 5 over 3 minus 1, so we can subtract them by finding a common denominator. So the denominator of 1 is 1. So we'll multiply the numerator and the denominator by 3. So we get 5 over 3 minus 3 over 3, which is equal to 2 over 3. So this should be the final answer for the derivative of part A. So now we can do part B. So in part B, the first step is to rewrite the expression by moving the x from the denominator to the numerator. So we get y equals 4, and then x to the power negative half minus 6 times x to the power negative 1. Now we can find the derivative. So we use the Leibniz notation. So dy over dx equals the derivative of, so 4x to the power negative half minus the derivative of 6 and then x to the power negative 1. Now we can move out the coefficient, which is 4. So we get 4 and then d over dx and then x to the power negative half. And now we can move out the coefficient 6 and then x to the power negative 1. Now we can find the derivative. So dy over dx equals, so we'll use the power rule. So we'll move the exponent negative half to the front as a coefficient and subtract 1 from it. So negative half minus 1. Subtract 6, then negative 1 times negative 1, which is the exponent, and then x to the power negative 1 minus 1. So now we can rewrite this as dy over dx equals, so 4 times negative half is negative 2, x to the power negative 3 over 2. Because negative half minus 1 is equal to negative 3 over 2, and then negative 6 times negative 1 is positive 6, x to the power negative 2. So now in our final answer, we can move these terms to the denominator to make the exponents positive. So dy over dx equals negative 2 over x to the power 3 over 2 and then plus 6 over x squared. So this should be the final answer for the derivative of part B. Now we can analyze part C. So first we can move the x cube and the x squared terms to the numerator. So we get y equals 6 times x to the power negative 3 plus 2 times x to the power negative 2 minus 3. Now we can use the Leibniz notation. So we get dy over dx equals the derivative of 6x to the power negative 3 and then plus the derivative of 2x to the power negative 2 and then minus the derivative of 3. So now in the next step, so we can move the coefficient to the front, which is 6, and now we can use the power rule. So we can move the 3 from the exponent to the coefficient and then subtract 1 from the exponent. Now for the second one, so we can move the 2 to the coefficient and then move the exponent to negative 2 down to the coefficient and then subtract 1 from it. And the derivative of the constant is 0. So we can simplify this as dy over dx. So negative 18, so 6 times negative 3 is negative 18 and x to the power negative 4. And then 2 times negative 2 is negative 4, then x to the power negative 3. Now in the next step, we can move the x terms to the denominator to make the exponents positive. So negative 18 over x to the power 4 and then negative 4 over x cubed. So this should be the final answer for the derivative of part C. So now we can analyze part D. So we can start here. So in part D, so the first step is to move this or change this radical into a rational exponent. So we rewrite this as y equals 9 times x to the power negative 2 plus x to the power half. Now we can use the Leibniz notation. So dy over dx equals the derivative of 9x to the power negative 2 and then plus the derivative of x to the power half. Now we can use the power rule. So first we can move the coefficient to the front and now we bring the exponent down, so negative 2 and then x exponent negative 2 minus 1. And now for the next one, so we'll move the exponent to the front, so 1 over 2 and then x half minus 1. Now we can simplify this expression, so dy over dx equals, so 9 times negative 2 is negative 18, x exponent negative 3 and then plus 1 over 2 x exponent negative half. So half minus 1 is negative half. Now we can write our final answer with positive exponents. So it will be negative 18 over x cubed and then plus 1 over 2 and then square root of x, because when we move x to the denominator it becomes x to the power half, so it becomes square root of x. So this should be the final answer for the derivative of part D. So now we can analyze part E. So I can use a different color. So for part E, so we are given three terms. Now two of the terms have x with the square root, so we can change that to rational exponent, but we don't need to do that for square root of 2 because it's a constant. So we can rewrite it as y equals x to the power half plus 6 x cubed to the power half and then plus square root of 2. Now we can combine the exponents in the second term. So x to the power half, and now we have to use the power on a power law of exponent. So we multiply the exponents. So we multiply the powers to get x 3 over 2 plus square root of 2. Now we can find the derivative. So dy over dx equals, so the derivative of x to the power half plus the derivative of 6x to the power 3 over 2. Sorry, and then the derivative of square root of 2. So now we can simplify this expression. So for the first one, so dy over dx, so we'll move the exponent to the coefficient level half and then subtract 1 from it. And then for the next one, so we'll move the 6 outside and then times 3 over 2 times x to the power 3 over 2 minus 1. And then plus 0 because square root of 2 is a constant. So now we can rewrite this as dy over dx equals, so we get half and then x to the power negative half. And then plus 6 times 3 over 2 is equal to 9. And then x to the power half. Now we can rewrite this in the form of the radicals. So we get dy over dx equals 1 over 2 square root of x. So because of the negative exponent, the x moves to the denominator with 2. And then plus 9 square root of x. So this should be the final answer for part E. Now we can analyze part F. So that we can do it here on the side. So I can just squeeze it in. So I'll use a different color. So part F. So the first step in part F is to break up this expression into two fractions. So we can write y equals 1 over x plus square root of x over x. And now we can simplify the second fraction. So it will be 1 over x. So 1 over x can also be written as x to the power negative 1. And then plus 1 over square root of x. Now we can rewrite this as y equals x to the power negative 1 plus x to the power negative half, because when you move the square root of x to the numerator, the exponent will become negative. So now we can find dy over dx. So it's the derivative of x to the power negative 1 over dx plus the derivative of x to the power negative half over dx. So dy over dx, so I'll just move it here. So dy over dx equals, so we'll move the exponent to the front, so negative x to the power negative 1 minus 1. So the exponent is just negative because we don't write 1 as in coefficient. So the coefficient is just negative. And now for the second term, so it will be negative 1 over 2, then x to the power negative 1 over 2 minus 1. So now I'll just squeeze it here on this side here. Right? So we get dy over dx equals, so we get negative x to the power negative 2, and then in the second term, so it's plus negative half, so it becomes negative 1 over 2, and then x to the power negative 3 over 2, because negative half minus 1 is negative 3 over 2. And now we can write our final answer with positive exponents. So we can move the terms to the denominator. So negative 1 over x squared, and then negative 1 over 2 x to the power 3 over 2. And we can change it into the radical. So we can rewrite this as negative 1 over x squared, then minus 1 over 2, and then square root of x cubed. So this should be the final answer for the derivative of part F. So these are the steps you have to keep in mind to find these derivatives. So it's very important to keep in mind the different steps you need to do to analyze these different expressions and then find their derivative. And it's also very important to memorize the rules for derivatives. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.